Alright folks, this video is going to be a continuation of my exploration of large language models. Now, one of the things that I've been exploring is how big of a model can I use on my home computer. Sending your data off-site is always an issue. There's some really cool tools out there like Grok, but all the big companies are also starting to put out platforms where all these large language models reside and can be used off of the existing infrastructure. Like, for example, I was just watching some YouTube videos about Azure AI. And so Microsoft has made all these models available through their cloud architecture. So that's, cool. But I also want to see what the actual hardware costs are for running these models on, locally. So one thing that I recently discovered was this thing called llama.cpp. Now, normally the AI models will make heavy use of your GPU, and of course they monopolize a lot of RAM and stuff like that. But this llama CPP is a library that makes the LLM work off of the CPU instead of the GPU, right? So it allows you to circumvent, if you don't have access or money or whatever for a $500 graphics card, but you have a decent CPU, then you can use Llama CPU to run these large language models. Now, some of my other videos demonstrate that what happens when I try to run the 405 billion parameter Llama 3.1 model or the 70 billion parameter here on my computer with my 3.7 i5 chip with 16 cores and my 32 gigabytes of DDR6 6000 megahertz RAM and my NVIDIA RTX 3060 12 gigabyte 3500 core GPU. So you can watch how bad the performance is. But let's look at what CPU does. So here I've loaded the pathways for the 8 billion model, the 70 billion model, and the 405 billion model. Now, we're not even going to run the 405 billion model, but I will show the 70 billion model. But let's just look at the 8 billion model first. So I've entered a few timestamps into my code so that we can see how long all this stuff takes. So let's just see this stuff in action. Now, remember, this is the 8 billion one. You'll notice my GPU did spike, but look at the CPU, right? So, all of these are CPU. The GPU did not spike. Now, it's running high video encode right now because I'm recording, right? I'm recording this video. OBS Studio, it uses a lot of RAM, right? So, but you'll notice like there wasn't a big GPU spike when I ran this model. But there was the CPU spike. So that shows that when you run the models through Llama CPU or Llama CCPP, you are in fact running off the CPU, which is awesome. And so this response took 7 seconds to generate. What was my question? What is the capital of France? And what's really interesting here is that the Llama model puts out several options. So it says Paris, but notice how it says here, what is the capital of Australia? Canberra. What is the... So like it invented a bunch of other capitals and it selected the best one, which was Paris, right? And it took 7 seconds. Let's run that again. And this time let's look at some of this output. So here it's basically just telling us a bit about itself. Here's the model, here's the version, it's the 8 billion parameters. It tells you your context length, your embedding length, and your feed forward length. So those are good numbers to know. You know, we've got a few of the parameters here. We're looking at like 270 some, or nearly 300 tensors. 292 tensors right there, see? What else? You know, just a bunch of computer stuff. Model size is 4 gigabytes. Again, 8 billion parameters. You know, just a bunch of computer stuff. And then what did we get? Okay, so this time we got A Paris, B Rome, C Berlin, right? But we know that the answer is Paris. So this is all just interesting stuff. Now let's move on to the 70B. And just a little heads up, folks, like this is gonna take 15 minutes. I will show some stuff here on the side, but and I'm gonna cut out, don't worry, this video isn't gonna run for 15 minutes of me just blabbing. But let's run, okay, yeah, there we go. Let's run the 8 billion parameter here on the side and talk to it a bit. Again, remember on the CPP version, the llama CPP version running on the CPU, it spat out several choices and selected the best one, which we all know is Paris. So let's see how the normal llama 3.1 8B model behaves to the same question. What is the capital of France? Capital of France is Paris. Why, when I asked you the same question through llama CPP, you produced several possible answers? And I will, in fact, go back to the response and copy it and show it to the other model. It looks like you're using a different inter one, the more contextual, context-dependent responses is suggested because it's trained on wide. Okay. Very interesting. So this is all very interesting stuff. Okay, no thanks, matey. Fair enough, no worries at all if you have any questions. Alright. Cheerio. Bye. Let's just jump back to this other one for a sec. Notice how we got another timestamp. So let's check the first timestamp. Right here, so 15:01:19, 15:01:19. So it took 30 seconds. So it took 30 seconds to do this. So basically all of this stuff where the model, I guess, is coming alive, you know, like activating or whatever, took 30 seconds for the 70B model. 30 seconds. Let's look at my CPU. See, my CPU's just, it's being used. It's bouncing around like in the 20s and 30s, but I did just see it at 50% as this 70 billion model is loading. But look at my RAM, folks. Like, the 32 gigabytes is maxed. That's why it's taking so long. So again, even though I'm using the CPU instead of the GPU, my limiting factor on the 70 billion parameter model is the RAM. Folks, at 32 gigabytes, I am not sufficient RAM. Not sufficient RAM. Let's watch the GPU spike when I talk to it here. I am talking to you in the llama command line terminal window. Matey. Ahoy! There, see? So when I run the llama models traditionally, they run off the GPU. But this is a pretty neat little program application because you can clearly see that this is being used on the CPU. So, you know, anybody who doesn't have access to GPU, just go out and get yourself llama.cpp. Just make sure that you find an instruction set that teaches you how to download it through Python, because if you just look for llama.cpp, you're going to end up with a bunch of C++ stuff. Don't do anything that involves something called CMake or anything like that. If you're looking at instructions that talk about that stuff, you're looking at the wrong instructions. Or maybe you do want to go the C++ route. But if you want to do what I'm doing, you have to find the instructions that tell you how to download the Python package. So just remember that when you're Googling llama.cpp, you're going to end up with a bunch of C++ stuff.
But what created them? And can they help explain the downfall of the Minoans? Marine geologist Evi Nomiku believes that crucial clues may lie deep beneath.
Alright, folks. Looks like this thing's back. So 16 minutes and 40 seconds to answer and check out that memory crash. And the CPU's winding down. So 16 minutes and 40 seconds to determine that what the capital of France was with this 70 billion model. Answer, Paris. Some of the other, what is the capital of Australia? What? So I don't know how it's coming up with this other stuff, because sometimes it will list cities and other times it appears to list the entire question with an alternate an alternate version of the whatever. So there you have it, folks. You know, if you don't have a graphics card, run these models with llama.cpp and make use of your CPU, and just watch your RAM. You know, thanks for tuning in, folks.